Alright, so now, like for number 10, number 10 on the worksheet is, it says you buy a new computer for $2,100. It decreases by 50% annually Now, this is where the question is different than the questions that we've had before. The question is, when will the computer be worth $600? Alright, so in this problem, we're running into a different type of problem. If we do our y, our c, our r, and our t, we actually know y. We know the future value here. The future is $600. So we know that's 600. We know the initial value is 2,100. We know the rate is 50%, which is a 0.5, but we don't know the time. We don't know the time it's going to take to go from 2,100 to 600. So we set up, is this growth or decay? It's decay. So it's 1 minus r to the t power. So we go y is equal to 600 is equal to 2,100 times 1 minus 0.5 to the t power. And so what we have to do is solve for t. Now, there are two ways you could go about doing this. One, is graphically, where we can take y1 is equal to 600, and then y2 is equal to 2,100 times 0.5, and then in the calculator we put an x. And so what will actually happen is you'll have a picture like this, and then you'd find that point of intersection. But that's not what I'm going to show you today. That's a way that you can solve any equation. Solve one, or graph one side, graph the other side, see where they hit. Where they hit is going to be your x value. But what we're going to do here this is something brand new for you. Totally brand new. We're going to use the natural log, which is the ln. So if you ever wondered what the ln key on your calculator was, this is part of what it's used for. There's more to it. There's a lot more to it. That's pre-calculus type stuff when you start to learn about the natural log. What we're going to do is we're going to use some of the basic formulas. Now, the formula we're going to use is this. If you have a natural log of any number raised to a power, this is equal to b times the natural log of a. So I'm going to ask you just to kind of believe this is true, because it works out 100%. And since everything that we're doing has to do with powers, this is what we're going to be dealing with. So this is how we would approach this type of a problem. We'd have 600 is equal to 2,100 times 1 minus 0.5 to the t power. What I want to do is first divide everything 100. So that's first. Divide by c. So you could divide out those zeros, 6, so those zeros divide out. 6, a 3 goes into a 6 2 times. How much does 3 go into 21? 7. So this is equal to, now what's 1 minus 1/2? What's 1 minus 0.5? 0.5 to the t power. So I did some division. Now you could have kept it as 6 calculator problem. That would have been fine. You could have said this was 600 over 2100 is equal to 0.5 to the t power. And this would have been new value. The old value, or the original value, you can set it up just like that. This is your 1 minus r, and there's your t. Model the situation to go y over c is equal to 1 minus r to the t power. That's basically what this is. Now, we're going to utilize the fact that we can do anything to sides. And what I'm going to do is I'm going to take the natural log of both sides. So this is the new step. And you really don't have to know what the natural log is in order to use it to solve this problem. So what I'm going to do is log of 0.5 to the t power. Since we took the natural log of both sides, I have the natural log of some number raised to a power. I can take that power and put it out in front as like a coefficient of the natural log. So I could take natural log, to do is I want to solve for t, so divide by the natural log of 0.5, divide by the natural log of 0.5, and now so we can go back and check to make sure that this is going to work. And to make sure that it's going to work, we go back to the original equation. The original equation is 600 should be equal to 2100 times 1 minus 0.5. And if I raise it to the 1.80735 power, what should I get? Just on this side of the equation. And that's 0.50. What's half of an hour? 30 minutes. So I even got down to 30 minutes.